So today I'm going to start a new chapter on order relation and lattice. So this is the lecture 1 of this chapter and we will start from relations. First of all, we have to know what relation is. Let A and B, two non-empty sets. A relation between two sets A and B is a subset of A multiplies B and is denoted by R or rho. Thus, R is a subset of A multiplies B. And for relation, there exist 2 to the power n to the power 2 number of relations on a set A having n number of elements. Now, domain. The domain of a relation is the set of all first coordinate of the ordered pairs in the relation. So, we have to memorize this one like the domain of a relation is the set of all first coordinate of the ordered pairs. So, this will be domain. And then the range. The range is the set of all second coordinate of the ordered pairs in the relation. Let me give you an example of domain and range. Let A is 2, 3 and B consists of 1, 2, 3, 4. Then the domain, as we know from the definition of domain, that the set containing the first coordinate values, so that is 2, 3. So the domain is 2, 3 and the range consists of second coordinate ordered pairs. So the range is 1, 2, 3, 4. So this is the example of domain and range. Now starting with POSET or partially ordered set. This is a very important topic of order relation and lattice. So many questions, explanation type, MCQ and other questions come from this section of relation. So let me take you to the definition. Let S be a non-empty set and less than equal to be a relation in S. Less than equal to is called a partially ordered if the following three axioms are satisfied. So now the three conditions. Now the first condition to be partially ordered set is for any A in S, we have A less than equal to A, and that is reflexive property. So this is the first condition to be partially ordered set. And now the second condition is antisymmetric. If A less than equal to B and B less than equals to A, then A is equal to B. And this property is antisymmetric. So this is the next condition to satisfy the partially ordered set. So that is antisymmetric, like A less than equals to B and B less than equals to A, then A is equal to B. So this is the antisymmetric property. Now the third condition is transitive, like if A less than equals to B and B less than equals to C, then A less than equals to C, and this is transitive property, like A less than equals to B and B less than equals to C, then A less than equals to C. So this is the transitive property. And the third or the last condition to satisfy partially ordered set. So the set satisfying these three conditions like reflexive, antisymmetric and transitive is called a partially ordered set or simply a POSET. And we write is less than equals to is a POSET in short form. And note, as discussed above, every two elements of S may not be related by less than equals to. Because of this, the word partial is used. Now, starting with precision and succession. In a POSET, A is less than equals to if for two elements A and B, A less than equals to B, we say A precedes B and B succeeds A.